Hi, this is Miss Goodale, and today's video is going to be about finding equivalent ratios. You may recall from a different video that I talked about finding equivalent fractions. I have notes that I passed out in class about finding equivalent fractions and ratios. The reason that it is both is because you use the same process. Fractions and ratios are very related to each other. They are just a comparison of one number to another. So with fractions, it's part to whole, or with ratios, it could be part to part, it could be part to whole, but it's comparing two numbers. So it's the same process for both. So this video might be fairly short. Just a review. If you want to find an equivalent fraction or equivalent ratio, you're going to start with a number, and you can either multiply or divide depending on the number to get an equivalent ratio or fraction. So on this one, I can't divide because one is reduced to a prime number. So I'm going to have to multiply times something to get an equivalent fraction. So whatever I decide to multiply, I just multiply the top and the bottom times the same thing. So if I take the top times 2, then I take the bottom times 2, and 1 times 2 is 2, 18 times 2, or 8 times 2 is 16. And that's the process that you would use. Let's do one with division. So if I have 5 and 15, those can both be divided by the same number. They can both be divided by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. Okay, so that's just kind of a quick run through of how that works. In your book, for this lesson on equivalent ratios, they also do tables. And you have to make sure that when you are doing the tables for those, that you pay attention to the comparison of the top number to the bottom number or the bottom number to the top number, not just going across, excuse me, because they don't always go in equal increments across. So just to give you an example of a table, I'm going to start with I'm going to try to find an example here that I can use. So let's say we're making a mixture of and in the book it gives you an example of orange juice to pineapple juice to make punch. I'll use the same concepts. I may use different numbers. So I'm going to have a label on the top and a label on the bottom. If it gives me a value for how much orange juice it takes for each thing of pineapple juice, I'm going to want to maintain that same ratio all the way across. So let's say I have 2 containers of orange juice for every 3 of pineapple juice. 2 and 3, I can't divide to get an equivalent ratio, so I would just multiply. So 2, let's do times 2 for the next one. So 2 times 2 is 4, 3 times 2 is 6. 2 times, let's do 3. 2 times 3 is 6. 3 times 3 is 9. 2 times, let's see, we did 3. Let's do 4. 2 times 4 is 8. 3 times 4 is 12. And you could just keep going. You will notice that this top column or top row is counting by 2s, and this one is counting by 3s. So sometimes when you do these tables, they might have a pattern. But like I said, sometimes they skip way ahead and do, let's say, 20, and then they might leave a blank. If you had a table like this and it asked how many for 20, you could still do that because you'd know to get from 2 to 20, I took it times 10, and you just do the same thing with 3. So 3 times 10 is 30. So you maintain the same pattern of multiplication or division from each all the way across. Just pay attention to what your table is doing. Okay, I think that's pretty much it for this video. In another video, I'm going to show you another way to do equivalent fractions and ratios if you have a missing number. That would be like the cross multiplication. That would be better for just missing numbers rather than finding equivalent fractions or equivalent ratios. I hope that this helped you clear up any further questions that you have, and let me know if you still need something cleared up. And thank you for watching.